section up and introduce Joe Arthur with Cisco. So with that, Joe, the show is yours.
Thank you very much, cStor, for having me today. Thank you all for all of you who have joined. Again, my name is Joe Arthur. I'm part of the data center team here at Cisco. We're going to talk a bit about hyperconverged and really why this trend is starting to pick up speed and what we're doing here at Cisco with cStor to help you, the consumer, capitalize on that. So if we look at, really what's going on in the data center space, or truly the IT space as a whole, we see these customer challenges, right? This desire to be able to move more quickly, to be more nimble, to be able to operationalize things in a more efficient manner so that we can actually, apply less people to get more results. And, there's a big desire out there today to avoid this need to really look at the business, say, 36, 48 months from now, and understand what sort of components we need to be buying today to deal with growth or change or whatever that might be. And so there's a desire to have really a more flexible consumption model. And we laugh because these are customer challenges, but truly this is why we see a lot of the organizations we work with looking at, options based in cloud, in a cloud manner. So the cloud, right, this ambiguous cycles from the ether is really addressing these. It's allowing people to have a just-in-time IT consumption model. It's allowing them to hand off some of the efforts that were previously required of their teams, and allows them to pay as they grow. So these, in fact, are a lot of the same motivators that we're seeing tied into hyperconverged. People want an easier consumption model. They want to be able to have that cloud-like flexibility, but they want to do it, in this case, on the on-prem fashion. They want to be able to do it while still owning the actual gear and the bits that sit on it. So what exactly is hyperconverged? Well, if we look at where we were previously, right, we had traditional approach where we had servers, and those servers were hosting applications. They were supported by CPU and RAM. Between the server and storage, we had some sort of storage network, either Ethernet or fiber channel, whatever that might be. And then we had the storage itself, right? The storage hosted some sort of cache, typically some spinning disk, and on that we had all the different files in a traditional NAS environment, hybrid storage, all flash, whatever that might be. But the challenge with this, as we have heard from our customers, is there's a lot of moving parts. There's a lot of points of management. Oftentimes, there's a lot of investment that has to be done in a predictive manner so that they know, that they can have the right cycles available as they move through the next 24 to 36 months. So what does hyperconverged do? It allows us to take some of these core elements, that CPU and memory, the cache, the disk, the network, and virtualize those components and bring them into a smaller number of devices that are set up in an easy to manage single clustered manner. What does that mean? It means that I can have all of these components in a single pod or a single cluster, manage them from a single pane of glass, be able to give the business what it wants, when it wants, that agility, that simplicity, but also doing so in a cost-effective manner. And that hyperconvergence layer is really the software layer that sits on top of all these components that gives us that storage advanced function that we didn't have in the past, that gives us that clustering ability so we know that we'll have highly available access to the data. Core components, core requirements in any type of hyperconverged or, quite frankly, traditional environment. We need to know that when the business needs a resource, that it's available. And what this does is it eliminates some of those constructs that were part of legacy environments, especially concerning the storage. It gives us a lot more flexibility. So if we take a quick step back and we say, well, hyperconverged architectures have been out there for a while. What's new? So if we look at this first bar, this is true, right? The first hyperconverged environments really brought simplicity to the market. They brought that single pane of glass, that much more easily managed environment, and they were able to do it quite quickly. And there were some steps that had to be taken in order to get these products to the market quickly. In some cases, it involved using things like open source file systems. And over time, we saw that some of these, right, these shortcuts that allowed some of the early hyperconverged solutions to come to market created some challenges, right? So in some cases, there were additional management silos. So if I had an existing compute and storage environment and I brought in a hyperconverged environment, sometimes I had new points of management that I had to get my team scaled up on. Scaling was often a challenge. These were appliances. If I needed any component within that appliance, I had to buy a new appliance. So if I just needed more compute and my appliance included compute and storage, well, I had to buy more storage whether I wanted it or not. And there were some performance challenges based on some of those underlying software elements that provided some challenges around scaling and performance for those applications that was somewhat undesirable from a lot of the customers we spoke with. So along comes this Gen 2 environment, these Gen 2 hyperconverged solutions, and what do they deliver? They deliver what people were looking for. They're looking for that agility. They're looking for that efficiency, and they're looking for that flexibility or adaptability so that they know that they can the number of cycles tied to supporting IT. They can scale much more efficiently, and in often cases, they can scale to a greater extent, and they're built, the requirements are to build around some of the next gen applications, some of these web scale type of applications. And this is what we put together when we developed the HyperFlex system. So what we took was our traditional hardware, right? So we would argue this is the first in a truly complete hyperconverged environment, because one of the gaps in the past was networking. We saw hyperconverged solutions doing a great job of virtualizing and supporting compute, network, and storage, but physically they didn't include all the hardware components to support that in an actual physical manner. Specifically, no other hyperconverged architecture included integrated networking, and this provided a gap, hurdle, because we were oftentimes left with whatever networking was available, whether or not that fit into the overall architecture and whether or not it could support the workloads of those applications. So with the Cisco environment, we included all those hardware components. We took our traditional UCS platform as that base, and we built upon that a layer, our hyperconverged layer we call the HX data platform, and that introduced these data services, that introduced this soft storage optimization, right? Those functions that we looked for traditionally in a more traditional storage subsystem. And really what this becomes part of a bigger picture data center strategy, and I'll talk about that in a minute. But the point is, it doesn't have to sit as an island, as this sort of unique little science project in a corner. We can tie it into the bigger picture initiatives that our partners and our customers have been looking for. So what all is included? The first is, it's a platform that delivers the ability to independently scale. And by that I mean that earlier challenge I spoke of, where in an appliance model I had to scale one appliance at a time anytime I ran into the need for some sort of resource that was within that appliance. So if I needed storage, but I had plenty of compute, it didn't matter. I had to buy a new appliance to get storage, which means I got more compute. In our case, we're going to provide a greater ability to scale within the node by adding more cache, more memory, or more disk for storage. We're going to allow for the inclusion of a compute-only node. So if all I need is compute, which is oftentimes where we see the first of the resources to run low, fantastic. I can take this storage, the storage node seen here on the screen, and next to it I can put one of our UCS blades in a compute-only capacity, so that it's able to offer a landing place for more VMs. But of course, this is a all-encompassing environment, so we want to know we have those storage features that truly have become table stakes for our customers. So we have pointer-based snapshots, we have cloning, we have inline dedupe and compression. So again, a differentiator between me and some of the other providers out there is that our dedupe and compression is always on. So all performance metrics that you see based on the HyperFlex platform, assume, right, that is what you will see as well, because that is not tuned, right, to avoid maybe some of the functionality you want in order to see performance. Inline dedupe and compression in other platforms provides a significant hit to the available compute resources. So oftentimes what we would see is performance metrics had a big asterisk, and if you read in the details it said, oh, by the way, none of that advanced function software was running in order to provide that, to provide those performance numbers. Ours was just the opposite, always on, always looking at the data and trying to determine where we can provide additional efficiency. We do offer a single point of management. So the actual management of the HyperFlex environment from a day-to-day basis will be performed in vCenter as part of the VMware architecture that's often in place already. So what we don't do is we don't say, listen, you need to learn our platform for management of all this. We're going to hand that off to vCenter. Behind the scenes, certainly for all of our UCS customers, we do have UCS Manager available and available to tune or to add a node if necessary. But again, from a day-to-day basis, that will just be an operation that goes on behind the curtain that allows folks to really take that platform they already know in vCenter, provide new resources to the business, and not have to go back and learn a whole new platform. And then it's really, we have an enterprise highly available architecture. These nodes are set up so that we can have a failure within a node, or we can lose a complete node and still be delivering the data back to the applications. The way we distribute the data, the way we tie in that HA functionality, it really is designed to be a non-disruptive fault type of environment. And again, this is sort of that 24/7 type of requirement that we're being asked for by our customers. So again, we'll build this out real quick, but what are we delivering? At the end of the day, if we move aside all of the speeds and feeds, we're delivering simplicity. Our platform shows up with those integrated networking modules and a set of nodes. 3 is our minimum. We work, again, with our partners like cStor so that they can help you really realize a more immediate time to benefit, right? Whatever that environment is that you need new compute for, you need a hyperconverged architecture for, you don't want to have to wait 2 weeks for all the components to show up and then for somebody to come in and tie them together. So the way we ship this and working with our value-added partners, these environments are much more quickly enabled and delivered in a manner that you can start to take advantage of those cycles. But once it's in sight, it is easy, right? It is that we automate some of the configuration elements for that day one implementation or to add nodes down the way. We're going to tie into that existing management planes. Today it's VMware. Soon it will be other virtualization offerings and hypervisors. But the point is, with each of these, instead of trying to hold on to management, we're going to hand that off to whichever hypervisor manager is preferred as we add these other hypervisors. And it is the entire stack of compute, network, and storage physically and virtually. We're giving people flexibility. Again, I can scale within a node if I need additional resources, be it cache or memory or disk. I'm going to be able to scale, by adding nodes if that's relevant or if that's appropriate based on how I'm consuming the existing, the existing components, or I can add a compute-only node where appropriate. The point is, we're not locking anybody into a single upgrade or really a resource addition methodology. And we're going to make it affordable. So if, again, our starting place is 3 nodes, you can scale and purchase, right, and pay as you grow as needed by your organization. So there's no nickel and diming that every time I add a disk drive there's going to be an additional charge. There's no requirement that a full node be utilized every time. In fact, if we look at those compute nodes I was speaking of, there's no licensing whatsoever to add compute nodes to an existing environment. So where do we see this being an appropriate fit? Today, there are 4 primary use cases. And I say primary because the truth is every customer environment is unique. And there may be an environment where every single compute and storage cycle may fit perfectly into a hyperconverged architecture. There may be others where that's not the case. In those cases, we might say, it might be that virtual desktop solution that people are, we've been talking about virtual desktops for many, many years. The truth is the economics didn't always align with the desire. And part of that was that some of the capital costs to provide the back-end resources didn't provide the ROI a lot of customers were looking for. Well, with every turn of the crank that we can provide greater economic viability to a VDI environment, then we have an opportunity to highlight really those benefits that were the original drivers for people to go down these roads. VDI instances are great candidates for hyperconverge. Server virtualization, a pretty generic term in all fairness. The fact is that we're looking for what I'd call those workhorse VMs and downstream from there. There are some very highly resource-intensive virtual environments that need sub-second latency. It might be an OLTP database, whatever that might be. The fact is, very high-end, ultra resource-intensive databases and the such are not good candidates. But everything else, again, as long as we validate, probably is. Test dev, where people want environments quickly and they want to be able to repeat them. Using clones, great candidate. Then large remote office, branch office. Anytime we don't want to have folks driving around to fix environments or fix that remote office compute resource, this is a great place to start. And the truth is, again, this is part of an architecture. So one of the values that we see in that elite group of partners like cStor who can look at your needs and determine where on this spectrum that compute, that storage should land. That's of huge value to us, right? Because the way we view HyperFlex, it sits into our bigger picture data center architecture. We can manage it under the same paradigm as the other elements, right? It's UCS servers at the end of the day, so I can still deliver that single pane of management across multiple of these pillars. But again, I couldn't stress enough, identifying the right resource for the right job is something that an elite group of our partners can do well. cStor is probably at the front of that pack, and being able to identify which are good HyperFlex candidates is something that I would highly encourage you to engage them in a discussion about. But the point here is we're not saying every single requirement out there, every single compute workload out there has to fit on HyperFlex, because unlike other people, we have other architectures that may fit that requirement more appropriately. So that is our HyperFlex platform. Introduced a few months back, been in the works for a lot longer than that, and truly it is a change to how we look at hyperconverged as an industry and how we deliver it. And certainly Cisco with cStor are here to help you take advantage of those, of those opportunities. With that, I'm going to hand it back to Kim for questions.
Awesome. Thank you so much, Joe. Great information. At this time, we'll open it up for questions. I would like to remind everyone you can post a question to the questions pane in your GoToWebinar control panel, and we'll take as many as time allows, and we do have a few minutes to fit them in, and here they come. First question for Joe. If I already own VMware licenses, do I have to buy new ones as part of the solution? Great question. I think a lot of unexpected or hidden costs can pop up, so great to dig into that. Joe, what are your thoughts?
Yeah, we have no interest in causing people to repurchase VMware licensing. Our value in this equation is that hardware architecture as well as that hyperconverged software layer. So we certainly will accommodate if someone needs a new VMware environment as part of a solution like this. We can fulfill that licensing requirement. But if you have licensing already, then we welcome you to apply those licenses to these nodes and take advantage of that investment you already have.
Awesome, thank you. Next question: when someone buys a storage node, do you have to populate all of the drives from the start? Great, also good question.
That is, because that was one of the challenges that we faced with an earlier hyperconverged solution that we saw out there. The truth is, no. We have, we typically start with 6 drives in one of those storage nodes, and again, we can scale based on what node it is, up to 23 storage, hard drives. So, no. The simple fact is, that pay-as-you-grow, that need to scale within the node is really part of the architecture and how we're packaging that. So not a requirement whatsoever.
Excellent. I'm sure that flexibility is a huge benefit. We do have time for a couple more questions. And next question also for Joe. If I already own UCS blade servers, can I reuse them on this architecture?
Yes, so blade servers, I spoke of being able to tie those in as a compute node. But the fact is that, yes, we can use up to 4 today based on the current release. We'll be growing that soon, and they can be assets that are already owned. The storage nodes themselves, existing UCS servers won't qualify because there's some additional just some background validation that has to occur for all the storage nodes. But from a compute perspective, if you have B-series blades and chassis in-house today, we welcome their inclusion as part of an overall HyperFlex architecture.
Excellent, thank you. I think you may have touched on this question, but we'll dig in and maybe there's a little more detail you can add. What is the minimum number of nodes in a supported system? I believe you mentioned that. Maybe I'm wrong, but was it 3?
Yeah. There is 3. There's basically there is a tie-breaking element that is part of that clustering software in the background that that really requires 3, and 3 aligns with the VMware best practice from years ago. There are other architectures out there who will allow for 2. In that case, that tie-breaking node is a virtual node. Quite honestly, there's some additional risk that gets brought into the equation when you do that. So today we're absolutely looking for 3 nodes as a place to begin and scaling out from there.
Excellent. Maybe just to follow on, are there any other sort of minimum requirements that folks should be aware of?
No, not really. So when we look at an initial footprint, it would be those 3 nodes minimum plus that integrated networking. They're what we call fabric interconnects in our traditional UCS environment. They'll be running a special code to work to really support that that layer 2 network in a HyperFlex environment. So, but the fact is we have bundles out there to allow people to very cost effectively consume those fabric interconnects and those first 3 nodes in a variety of configurations to align with the requirements for their specific needs.
Excellent. Thank you. Makes sense. Looks like we're just about out of time, but before we let everyone go, thank you, Joe, and thanks to the audience for the great questions.